Okay, so let's finish up chapter 1 with section 1.7, analyzing puzzles and games. And actually, this is one of the things that I find most enjoyable about math, the many things, haha. But I like puzzles and I like games, and I like how math can help you use deduction to figure out some puzzles and games. So it says keep in mind that inductive and deductive reasoning are useful for solving a puzzle or creating a winning game strategy. Remember, inductive reasoning is examples, where deductive can kind of cover any kind of situation that you can think of. Inductive reasoning is useful for games and puzzles that require recognizing patterns or creating a particular order, but deductive reasoning is useful for games and puzzles that require inquiry and discovery to complete. So remember, inductive is like the exact thing that's happening in front of you, where deductive is using a pattern. Okay, so Sudoku is an example of a puzzle, and if you already know how to do Sudoku, you could go ahead and move on from this, but if you don't, I will teach you how to do one of these puzzles. So it says to solve a Sudoku puzzle, you need to fill each empty square with a number from 1 to 9, and a number cannot appear twice in a column, a row, or a 3x3 block square. So let's get out the highlighter. Okay, in Sudoku it means this square here needs to contain the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9 only once, okay? So because there's already a 9 and a 6, these leftover 7 numbers can't be a 9 or a 6 because they're already there, okay? In a Sudoku puzzle, you need to have 1 to 9 in a row, and you also need to have 1 to 9 in a column, okay? So 1 to 9 in a box, 1 to 9 in a row, 1 to 9 in a column. And so they can be, that can be useful because what you do is you look at what you already have, and then you see what's left, okay? So this particular puzzle is asking for what's in A and what's in B. And so lots of people do these puzzles differently. Lots of people will write every single possibility in every square and then cross out what's not possible. I like to only write in a square what it could be. Okay, so let's start with A. And remember that in this 3x3 square, I can only have 1, 2, 3, 4, 5, 6, 7, 8, or 9. In this row, I can only have 1, 2, 3, 4, 5, 6, 7, 8, or 9, and then in this column. Okay? So there's lots going on in this row, so let's use that to start with. Okay, so in here, I couldn't have a 1, I couldn't have a 2, but I could have a 3. So I'm just going to write that on the side for now, because there is no 3 in this row. I could not have a 4, I could not have a 5, but in this row, I do not have a 6. I do not have a 7. I do not have an 8, but I have a 9. Okay, so in this row. Now look at it in this column. I already have an 8, so I'd cross 8 out. Okay, because this can't be an 8 because I already have an 8. Couldn't be a 6 because in this column I already have a 6. Okay, and then in this 3x3 square, I already have a 7. So the only possible thing that A could be is a 3. Has to be a 3. All right, now let's move on to B. Let's do the same thing. It could be a 1. It can't be a 2 because the 2 is already there. It could be a 3. It could be a 4, a 5, can't be a 6, a 7, 8, or 9. Okay, can't be a 2 or 5 because of the column above it, so it can't be a 2 or 5. Can't be a 5 because a 5's in the 3x3, and an 8's in the 3x3. So it could be a 7, a 9, a 1, a 3, or a 4. So based on what I've done so far, I'm kind of stuck. But what I could do is, if I can't do this square right now, I can do some other things. Okay, I could see what possibilities are in other squares, and hopefully eventually I will deduce that it can't be any of these except for 1. So let's see what else is possible. Okay, well, if I look in this row here, I have a 4. Okay, And if I look in this row, I have a 4. So because there's a 4 in this row, there's a 4 in this row, here I have to have a 4. Okay, in one of these 3 squares. Because in this row I have a 4, in this row I have a 4. So a 4 has to be in this row, but a 4 can't be here because I already have one there. And a 4 can't be there because I already have one there. Okay? But look at how I already have a 4 in this row. So the only place the 4 can go is right there. So B has to be a 4. So in order to solve Sudoku puzzles, it's a process of elimination, is the way that I mostly solve them. Okay? Sometimes you need to work 2 or 3 steps ahead to be able to get the square you need. But there's lots of little tricks that if you like these kind of puzzles, you'll pick up as you go along. Okay. Second is a Kakuro puzzle. I certainly haven't done many of these, but they're kind of similar to the Sudoku. It says that you need to fill each empty square with a circle from 1 to 9. And in your book, you've got this, there's an A and a B, a C, D, E, F, G, H. I just erase them so that I can actually write numbers in here. Okay? So you need to fill each empty space with a number from 1 to 9. Each row must add up to the circled number on the left. Okay? So look on your paper. I made this puzzle on my thing here. I didn't circle. I guess I could. So if I want, I can stick a little circle like it is exactly on your puzzle sheet. 6 in a circle. I tried to make this one up. Almost there. And 5 in a circle. Okay. So, let me see. Hold on, I'm going to lock all that down so I don't accidentally drag them. Okay. So, it says each row must add up to the circled number on the left. Okay, so these 2 numbers here have to add up to 4. These 3 numbers here have to add up to 6. And these 3 numbers here have to add up to 11. Each column must add up to the circled number above. So these 3 add to 7, these 3 to 9, and these 3 to 5. And then like Sudoku, a number cannot appear twice in the same column or row. Okay, well, that should be an N there. It's not very good spelling. It's a typo. Okay, so let's see what we can do. Hold on. There we go. Okay, so because this has to add to 4, it can't be 2 plus 2 because it says a number cannot appear twice in the same row. So it needs to be 1 and 4 is a possibility. No, 1 and 3, not 4. 1 plus 4 doesn't add to 4. It's either going to be 1 and 3 or 3 and 1. I'm not sure what order it is yet. Okay, either 1 and 3 and 3 and 1. You know what? Because this number's smaller than this number, I tend to put the bigger numbers under the bigger number. Okay? So then what I would do is I would play and see what's possible. So I need a 6 here. And because this is a 5, this is either a 1 and a 4 or a 2 and a 3. Okay, so let's see. This has to add to 7. So if I put, let's say, a 4 and a 2, I have 1 plus 4 is 5 plus 2 is 7. So far that's good. But you know what? This is a 6, and if I already have a 4, the only thing that this could be is a 1 and a 1. And then I can't have that because I can't have 2 1s. I can only have 1 of each number. So let's change it and make it a 2 and a 4. So I try some things, and then I see if it works or not. So if I make that a 2 and that a 4, which kind of makes sense because that's an 11 anyway, and that's bigger. So 4, 5, 6, 4, 5, 6, 7. Okay, so the 7's good. The 4's good. Okay, so I have a 6 going on here, and I have a 5 here. So 6, I already have 2. I only have 4 more to go. So let's try 1 and 3. So if I have 6, 2, 3, 4, 5, 6, that works. All right, 9. I already have 4, so let's put a 5 there. 5, 6, 7, 8, 9. That's done. And then 11, I have 4 plus 5 is 9. And look at how that 2 makes that 11 and makes 3 plus 2, 5. So I can't have any number in the same row or column. I have a 1, 2, 4, 3, 1, 5, 3, 2. So there we go. I managed to solve that. All right. So these ones are just sort of guess and checking. I don't have a better way other than, the bigger numbers kind of go in the bigger columns and think about what's a possibility to add to certain numbers. Okay, last example is called this prisoner's dilemma. And the prisoner's dilemma is actually sort of a famous puzzle. I tried to look on YouTube to see if I could find someone that could explain it better than I could, but the only problem was their prisoner's dilemma was slightly different than the one in your notes, and I wanted to keep the same information as was in your notes. So it says in the prisoner's dilemma, 2 prisoners are being held by the authorities in separate interrogation rooms. So it's 2 people that have done a crime, they were caught, and now, like we see on TV, they're in 2 interrogation rooms, and they're being questioned on what they did. So each prisoner has the same options. He or she can cooperate with the other prisoner by remaining silent. So if they both keep quiet, then the police are never going to know what happened. Or they can defect, which means they're going to defect from each other. They're going to confess to the authorities. They're going to rat out each other. So the results of cooperating or defecting depend on what both prisoners do. So if both of them cooperate, and I think it's easier to just think if they both stay silent. I'm not a fan of this cooperating word. And notice up here I highlighted silent and confess because that makes a little more sense to me than cooperate or defecting. Okay, so I'm going to use the word silent and confess. So if both prisoners stay silent, okay, they don't tell the police what's happening, they are each sentenced to 1 year in prison. So the police know they did something wrong, but they're not sure exactly what they did, or they can't quite prove everything. So if they both stay silent, they only get a year each. If they both confess, they are each sentenced to 3 years, okay? So now they're saying, this is the crime, this is what we did, but we're confessing. So it has to be a greater sentence because they are confessing to a crime. But if one stays silent and the other confesses, the confessor only gets 6 months because he told the police what they wanted to hear, but the person that stayed silent gets 10 years, okay? So this is the dilemma because these prisoners are separated and they don't know what each other is going to do. So when they were told their options, they weren't told together, they were told separately. So each of the prisoners doesn't know what each other's going to do. So it says, what would be the best thing for the prisoners to do, and what sentence would they get if they knew each other's decision? Well, that's kind of easy. If they each knew each other's decision, I made up a table here that we could kind of keep track of what happens. Okay, so if both stay silent, okay, this is prisoner A here. Let's get a pen going. So this is prisoner A, and this is prisoner B here, okay? So prisoner A can either be silent or confess. Prisoner B can either be silent or confess. So remember, if both stay silent, they each get 1 year. Prisoner A gets a year, and prisoner B gets a year. If they both confess here, if they both confess, each gets 3 years, okay? But if one confesses and the other stays silent, the confessor only gets half a year, but the silent gets 10. Okay, so the person that does the ratting out only gets half a year because they told the police what they want. The person that stayed silent gets the sentence, and then the other way around. So if the first person stays silent, he gets 10 years if the other person does the confessing. Okay, so this is kind of what's going to happen. So it says, what would be the best thing for the prisoners to do, and what sentence would they get if they each knew the other's decision? So obviously the best thing that they should do is both stay silent, okay? If they know each other's decision and they can coordinate what they're going to do. They're both only going to get a year. And in terms of, they both shouldn't confess because they'll both get 3. I don't think that each prisoner would take the fall for the other. Like, clearly, if you do the confessing and the other person stays silent, you're only going to get 6 months versus 10 years. And 6 months is less than that full year. But if they knew each other's decision, this would be the best option for them. But B says, what do you think they will actually do? And what sentence will they get given that they do not know each other's decision? So looking at the table, what do you think that they would actually do? Okay, so remember, they're segregated from each other. They don't know what each other's going to think. They already sort of are unsavory people because they're prisoners. They've done a crime. So do you really think that they can trust each other? So what do you think that the prisoners will actually do? I think that they probably would rat each other out. Okay, I think that they know that if they are the person that confesses, they only get half a year. I don't think that they're going to trust each other to stay silent and get that 1 year. So I think what's going to happen is that they both confess, getting 3 years each. Okay, it doesn't really seem worth it to be completely silent because they're not going to trust each other to both be silent. And remember that if the other person confesses and they're silent, they get that 10-year sentence. So I think they will both confess, which seems to lessen their chances of being there for 10 years, and they're both going to get 3 years. Okay? So if you want, go to YouTube and put in Prisoner's Dilemma. I know there's other versions, like if you confess, you get nothing. And if you confess, you only get 5 years. There's different versions of the Prisoner's Dilemma. But if you go to YouTube and look it up, you might get a better explanation if this wasn't understandable. All right, so we are done. Reasoning, Chapter 1.